Basically, I thought I'd make a video today. I'm a member of a few forums, and it keeps coming up about people powering lights, or be it retracts, any auxiliaries off Flywing Helicopter. Now, there's certain ways to do this. There's more than one way. I just thought I would share my method, which is a safe method and a sensible method and an easy method to use on these Flywing helicopters. Um, there's a quick demonstration of my Airwolf there flying in the distance. I'll try and be as quick as possible, but yeah, I thought I'd try and I'm going to break this video down into certain sections, and people need to understand why not to power from the Flywing helicopter, how my modification works, how to make my modification, and then I'll show you how to program the standard TX and get all the switches working and everything, and then I'll give a quick demonstration after. But I'll split this down into several sections, and yeah, welcome aboard. Here comes the next part.
Right, so here we have it. We're at my bench now. Welcome to my bench. Excuse the mess. It's always a mess anyway. I haven't got much room on my workbench, so it tends to get a bit cluttered, but regardless of that. Right, what Flywing tell us? As we all know, as Flywing owners, they tell us what we should never do is draw a current from the receiver. This is obviously the Flywing standard receiver. What they tell us to do is to never draw a current from the receiver. And we constantly get people on these forums saying that, oh, I just connect to channel 6 and I power my lights off that. That's fine. You should not do this. Flywing specifically states in their manual that you should never draw a current from the receiver. And there are reasons for this, but people tend to ignore it. Not only that, they then advise other people to do it, which is just wrong. You shouldn't be advising people to go against manufacturers' recommendations. Now, I'm following manufacturers' recommendations here, and all the way through this process of fitting lights to my Flywing helicopters, I have the Airwolf, I've got the FW450, and I've got the Huey QH1, which this is the mechanics for here. But anyway, what they tell you is you should not be drawing this power. And throughout my light install, I was conversating with Peng Pilot, who is the CEO of Flywing. So I just kept on going until I managed to get a system that was acceptable to power this helicopter. And we're obviously going to go through all of this now. But there are reasons why they tell us not to draw power from the receiver. And the reasons is the receiver, should I say this receiver, is powered from the helicopter, and it's actually taking the power from the H1 unit. And the H1 unit is taking its power from the BEC inside the ESC. So this is all designed by Flywing as one unit, and it's all designed to work as one unit. It's pretty much, they're at the maximum. We've had stories of ESCs burning out, BECs burning out, H1 units burning out, and these things happen. They don't always happen for this reason, but they can happen for this reason because people put an extra load onto it. So this is why Flywing tell us never to take a supply from a receiver, because when we take a supply from the receiver, this current and this charge, this draw, whatever you want to call it, is coming from here. This is running at 7.4 volts. This is running at, it's all running at 7.4 volts. But anything you add to your receiver that draws a current is going to draw more current through here. And yes, a million times it will work, or 1,000 times it will work, because, especially with lights, because lights are a very low current at the end of the day. But you are at risk of failure by doing this. You're at risk of overheating your H1, and you're at risk of overheating your ESC. Drawing too much power from them will overheat them. If they overheat, you'll either fry the fuse inside the H1, you'll melt a chip in the H1, you'll fry the BEC in your... There's just loads of... These are the reasons why Flywing tell us not to draw power from the transmitter system. So it's always advisable whenever you, it's not just for Flywing owners, it's really for anyone that uses a H1 unit that's being powered, that's powering the TX, because there are some different ways, I won't go into that. But if you're using a H1 unit that is powering your transmitter, never, and this is Flywing and this is in the H1 manual, never draw a current from this unit. And it's just, yes, a million times it will work, but one day it could cause issues. And all it takes is for either you to draw too much power, or say maybe your light circuit to fail. And when that happens, you'll get a surge of electricity to go back. It will go back into your receiver. It will go back into H1 and it will fry it. And at the end of the day, if you're in the middle of flying, we all know what's going to happen if your ESC, your H1, your anything fails in mid-flight. What's going to happen? Your helicopter's going to fall from the sky and it's going to smash to bits. Depending on where you're flying, you can hurt people, you can injure animals, you can damage people's property. It's not just about your helicopter, you know, it's about being responsible for other people at the same time. And yet people are still advising people just to just power it off there, mate, you'll be fine. It works for me. It does work, but it's not responsible. We need to be responsible as pilots, hence why I'm making this video. I'm getting frustrated at just explaining the same thing over and over and over again, because people generally just, well, it's not people don't listen, they do, but you get a lot of newbies on these forums coming in with their new helicopter and, oh, what can I do this? And you constantly seem to be explaining yourself time and time again. Sorry, I'm not thinking about what's going on with this camera, I'm just talking. But anyway, that's the reason we should never be drawing power from our receivers, because you're at risk of burning out another component, be it your H1, BEC, ESC, whatever. So do not draw a current from here. So now I will go on to part 2 to explain the next bit. Thank you for listening so far. Right, back to the bench for part 2. Right, this is all about the auxiliary switching system that I use to power lights on my helicopters. On my Flywing helicopters anyway. So basically I order a switch off Amazon. Just go into an Amazon type engine and type in auxiliary on off switch RC, and you'll get these 2 different types come up. You'll get this type, which is brand new in the bag, and you get a few other bits and these and stuff like that as well. But this is what you basically get in the package, is this. And there are 2 different versions. There's a 4 amp and an 8 amp. It's not just the amperage. There are a couple of differences between the switches. I won't go into them. All I will say is you need the 8 amp version, which currently I'm in the UK. It's priced at £7.99, I believe, and it's £6.99 for the other version. But you can physically see the difference. With the 8 amp version, you have 2 wires here on this side. One is for your battery, because your batteries, this switch is independently powered, or it's going to be anyway, and then one feeds your auxiliaries. With the 4 amp switch, you only have 1 wire on it. So if you see one like that on Amazon with 1 wire, that's not the one you need. You need the one with 2 wires on this side. Basically, the one with 1 wire, what that does is when this plugs into the receiver, whatever auxiliaries you're powering this way, all the current and signal is being drawn from the helicopter itself. When you use this type of switch, you add a battery. Personally, this is the one I use. I put this battery in on that side, and then all your auxiliaries are powered by a battery rather than drawing power from the helicopter. So that is why it is important when you look at these switches, do not get the one with 1 cable, get the one with 2 cables, because this is the only type that will work and is safe with my conversion. Right, so there's that bit over and done with. So when you get the switch from Amazon, brand new, or wherever you get it from, again, it's not affiliated, it looks like this. There's your auxiliaries, and notice that. And that is basically what you get. Now, I've modified one of these switches, which is there. Exactly, looks pretty much exactly the same. It's got the same 2 on there. It's got the wire going from there, but notice one big difference. The one big difference, I'll give you a couple of seconds to see. It's not hard. This one has no red wire. So this is my modified switch, and I'll quickly explain to you how to modify this switch. And like I said before, when I was speaking to the owner of Flywing Pain, trying to get my design, when I emailed this switch to him, and I said, can I use this switch on a Flywing helicopter? Because at the end of the day, this type of switch, as I explained with the current, the auxiliaries are actually powered by this battery. So the auxiliaries won't be taking any power from the helicopter. I put this in an email to Peng, and he said, do not use this switch on the helicopter. This switch will cause systems, as explained in chapter 1 when I explained about surges and stuff. Because when you use this switch as standard from wherever you buy it, you have this red wire, which we all know, white is signal, red is positive, black is negative. Obviously, with the red being positive, this is the wire that draws current. So this is the one that is the problem. So to enable us to use this switch safely, to be able to power lights and switch lights independently, like I say, there are other ways where you can do it, but I'm not going to go into that. This is my method. There's other ways you can power it, but I like, because some people will power it off the main battery. Like I say, I'm not going at, my method isn't to power it off the main battery. My rig is completely away from the helicopter. The power supply for the lights is all completely independent, so there's no chance of there being any issues. So basically, rather than using one off the helicopter, I use a little battery like that to power my light system. But basically, yeah, the difference is, here is my modified switch again. Like I say, the red wire has been removed from this switch. So now when you connect, I'll get rid of that one because we don't need that anymore. When you get my modified switch and you plug it into channel 6 on your receiver, by the way, if you're obviously this is about Flywing helicopters, channel 6 is your only option. That is your spare channel, and I will in another chapter show you how to program channel 6 and get it working properly. But anyway, this is going to plug into channel 6, but now this red wire has been removed. There is no chance that a current can come from this switch into that helicopter. It cannot draw it. The red wire, the draw is gone, the current is gone. So you've taken away exactly what Flywing tell us to do. Never draw a current from the receiver. By removing this red wire, we can no longer send a current to it. We can no longer receive a current to the helicopter. So we've bypassed it completely bypassed it. So that's the solution to adhering to the manufacturer's recommendations, where they say do not draw a current. After I designed this switch, I designed it, I sent the information to Peng again via email, and I said, can I use this my switching system now? And his reply was, yes, you can use that. That is perfectly safe to use with Flywing helicopters. Feel free to use it as much as you like, as it doesn't draw a current from the helicopter. And this is the owner of Flywing. That was his exact comment when I showed him what I had done with a modification with this switch. So now I will go into brief detail in how I modified this switch. It's really easy. There's two methods really. I've taken the harder method because it's tidier. I'll explain why. There's an easier method. So basically, the original switch there, you've got the red wire. Basically what you need to do, you just get a little screwdriver in there, take the tab out, remove this red wire from here, as you can see. Right, I'll get rid of that now. So red wire is removed. Now, what you can do, basically what you need to do is, beforehand, when all that red wire was doing beforehand was it was drawing a little bit of current to the switch, just to power the switch and the little LED, and that was it, because the switch is basically a gate. So the electronics are off. When the gate shuts, it makes the contact, and then it will send the power to your lights or your retracts or whatever like that. So this switch actually just draws very, very little power, and that's what that red wire was doing. That red wire was powering this switch. So, but even then, even though it was such a low draw just for the switch, Peng, the owner of Flywing, suggested not to use this. I was very surprised at that. But anyway, because that's such a low current. But so to bypass that, what I have done is, I don't know if we can zoom in enough now and we can see it, because I've taken the more complicated option. I'll explain them both. You can see with that red original wire now. That red original wire goes around to the back now, and see there's a positive there, and it's soldered to the soldering board on basically onto this red wire, which then your battery goes to. So now what we have is this battery is powering the switch, not the helicopter. So the switch is completely independently powered. It's not powered from this, which is what we're told not to do. It's being powered from this. Safe, good. It's exactly where we want to be. But I have gone the complicated route, like you can see. What I did do is originally, I'll get the original switch again, got the original switch. I cut the heat shrink off. I removed the red cable, and then as you can see from that one, I've taken it around the back of the circuit board, and then you take it to the input side, and the input side is the connector that your battery is going to plug into. That's the input side. So then you take that cable, and if I take it here, look, in positive. So that red cable from your receiver plug, your tablet plug, whatever you want to call it, this red cable has to be attached to this point here where it says in positive, which I have brought it around and soldered it to this junction. That's what I've done with my switch. You can't see it because it's been taped up and there's old glue on it. You can't really see that very well, but basically I've brought the wire around and soldered it to that point, which is the positive in. And then what I've done is I've put a new bit of heat shrink on my modified one because I've cut this heat shrink off, put it on, and I actually peeled the label. I'll get the focus in. I peeled the label off, and I even managed to put the label on as well, just to make it tidier. But that's the complicated way to modify this switch. There is an easier method. That's just me trying to be neat and tidy. That's the way I like it. And because I'm not too bad with soldering, and I like soldering, and I don't mind. But if you're somebody that doesn't like soldering, this is another version. This is the way to do it. You don't have to go to the extent I went to. All you basically have to do is from the original one, you remove your red wire, and then on your input side again, it does say on the back of the switch, which is your in, which is your out. So that's your battery, that's the in. So all you have to basically do is on a new one is cut this wire here. I'll bring the new one over, it's easier to explain. Is on the input, you basically cut this red wire here, and the red wire that you've removed from here, you attach to this red wire. Obviously this red wire is going to be cut, and there's going to be two sections. All three sections obviously need to be connected, so that red wire needs to be connected to this wire when it's been cut, and then you connect this to them as well. Do that however you like. Solder it, use connectors, tape it. That's your decision. Obviously make it safe. You don't want it coming loose. It's got to be a good connection, but you don't have to go to the extreme where I've removed the heat shrink, taken the cable across, soldered it to the right thing. I just like it neater. You can imagine if you do it the other way, you take this red cable out, then you've got a red cable that's going over to here, then you've cut this, you've got some connections. It's just messy, and you've got a chance of maybe this connection being bad if you screw it up. I don't know. That's down to you. But for me, the easier, tidier method is this one, was basically just to take the wire and solder it onto this point here, which just makes the whole thing work better. And I'll see if I can show you how I mean by that. If I take this, I wonder if this is going to be tricky. I'll just put the camera down a sec. Right, bear with me. I'm just plugging the battery into, right, I've just plugged that battery into that brand new switch. As you can see, you wouldn't know this, but should be a blue LED on there now. But there's no blue LED on there because that red wire has no power. So this doesn't work. So if we disconnect the battery from the brand new switch, after my modification, when I've taken the red wire out and put it across there, I'll put the camera down again. Bear with me. Right, I'm just plugging my battery into the modified switch, and there we have it. I've plugged my battery into the modified switch, and all of a sudden we have a blue flashing light. That's because the red wire here is here powering a switch. So this switch is now powered. It's not even plugged into the helicopter. This system is completely independent of the helicopter, and it will not send power to it or take power from it. And when all you're really using is the signal wire, to be honest with you, but you can't just put the signal wire. If you didn't put the neutral there, the switch wouldn't work. It's weird. I tried different methods, but you have to have both of these wires. But yeah, basically that's the switch working independently on its own. And now when you send a signal through this wire to close the gate to make the connection, you'll basically have the gate, it will shut, close the connection, then the current will get drawn from the battery straight into your auxiliaries, whether it be lights, retracts, whatever you're powering, that's extra. But yeah, as you can see, an auxiliary switch working on its own without taking a supply from a helicopter. So this design is perfect for a Flywing helicopter. And like I said, after I'd done this and showed it to Peng pilot, he said this system is perfectly safe to use with a Flywing helicopter. And another benefit I will mention is, like I said, there are other methods of powering lights, and there are different ways of doing it if you know what you're doing and you've done this many times. But every lighting system is different. You might have a lighting system that's 4 to 6 volts. You might have a lighting system that's 9 volts, 12 volts, whatever it is. Normally in these situations, we use something that's called a UBEC, or in the Flywing Heli, it's a BEC because it's in there. A UBEC, it just mostly means it's universal. So you have to use a universal UBEC to power to take the voltage down from your lights, because people will take the 14 volts from the battery, which means they've now got to knock that for. So it's just things like that. Using UBECs complicates the system. With my system, if your lights are 4 volts, you use a 4-volt battery, and you'll only ever get 4 volts come out of here. If your lights are 9 volts, you use a 9-volt battery, and only 9 volts are good. So that bypasses the need for any UBECs, BECs, whatever. You don't need them. Whatever your lights need, you give them. It's as simple as that. And then that just bypasses that part. That's what makes this system so simple. This is all you need to power lights off a Flywing helicopter. And then all you have to do is plug this into channel 6 with the white wire up the top, signal wire up the top. And channel 6 on the FlySky receiver is the second one in from the end. It's not quite the end one. If I bring that one in, it's this one here. So yeah, basically there you go. That's the switching system that works safely on these helicopters. Right, there we go. I thought I was going to do it in more sections, but I covered the last section in 2. So this is basically probably going to be the last section now. This is basically how to program your FlySky TX. So what we basically do is turn it on. I will actually supply power to my, excuse me, that's power to the heli as well, so I can do my demonstration. Right, so when your FlySky TX is powered up, right, that's just the FW450 doing its little swash dance, excuse me. Right, this is what will happen when you turn on your TX. So hold your finger and unlock the screen. Gotta hold it down for 2 seconds. You know, that didn't hold it properly. Hold it down for 2 seconds. Unlock screen. Screen is unlocked. Now I can go into the menu. In this menu, oh, endpoints. I don't want to go there. I want to go. You want to find auxiliary channels. You know, they're not great screens on here. They're really blurry. So there you go. You've got auxiliary channels. So if we select auxiliary channels, and now obviously we're connecting our lights or auxiliary to channel 6. So find yourself channel 6 by going across there, and there we go, there's channel 6. Now basically this one here, if you press that, is what switch you want to program to channel 6. So STX is your sticks, SWX, so sticks being sticks, SWH is switch, these are switches, VRX are variable switches, which are on the side, and key are the 2 little buttons that are at the back, the silver ones. If you want to use lights, you really need to use the variable X, because if you use the key, you have to keep your finger on it constantly to keep your lights on. It's not an on-off switch, it's just like quickly on, but as soon as you take your finger off, the power kills. So you really, if you're using lights, you need to use your variable X, variable switch. So then you can select switch A or variable B. Switch A is on the left hand side, B, A, B. So whichever the switch you want to use to power your lights. So let's say we want to use variable switch B, which is this one. So now we have set variable switch B to power the lights. So no matter what, that should power lights. So should we test this theory? So right, let's just go back out that screen. I'll just make sure I've got connection with my helicopter. Yeah, we're all connected. We've got systems functioning. Let's just go back to the main screen. Right, there we go. So we've just programmed channel 6 to variable B, which is this one here. And there we have my modified auxiliary switch powered with a little 3.7 volt on cell LiPo. And then it's going around there into channel 6. Please note you have to have the white wire at the top and the black at the bottom. It won't work otherwise. And it's, like I say, it's one from the end. It's not the last one, it's that one. It does say on, if I can focus in, it does say channel 6 is that one. So make sure white wire is at the top, channel 6. And then, right, so helicopter's all ready. If I power up the switch with the battery, there we go. Switch is powered up with the battery. And I've actually made a mistake there somehow because I've still got a blue flashing light. No, I haven't. It's working. Right, so yeah, sorry, I thought I had done something wrong for a second then. But it's absolutely working fine now. So as you can see, this receiver running off, this switch, so as I say, is running off of channel 6, signal wire at the top. We programmed it in to variable B. So when I go over to the system, you press variable B. Sorry, it's that way. It's on, off, on, off. If you look at the switch, on, off, and there's a little LED being powered from the switch just to demonstrate the system working. So there you go. That's how you do it. And just to show you again, it's on, off, because we programmed variable B to power channel 6. And there you go. That's pretty much as I can say on wiring up these. So please guys, you don't have to take my advice. I'm really just posting this video because I'm fed up with explaining this to people on forums, and it's so hard to type this every time. Painful. It's so painful. So I just thought I'm going to make a video. If anyone's got any issues, I'm just going to give them the link to this video. It's as simple as that. What I will try and do is, trust me, I'm no expert at video editing, YouTubing stuff. I don't know. I know my RC. I don't know computers and edit. I'm trying to suss out how to edit videos and stuff right this minute. So that might not be of great quality, but hopefully the information has been of great quality. So I'll pretty much leave it there now. And thank you for watching. If you found this useful, just give me a thumbs up. You don't have to, it don't really matter. I don't really care about views and pleasing people. This is just purely just to get some information across on how to power lights safely from a helicopter like a Flywing that uses a H1 system. At the end of the day, we all want to fly safe. Not even if you don't want to fly safe, you don't want to destroy your helicopter unless you're made of money and you're just a complete idiot. But anyway, this is my video on my best version of a lighting rig for a Flywing helicopter. Hope you enjoyed it. Take care of yourselves and happy flying.